CMOS technology. The topic of today's video session is design of multiplexer using transmission gate. Hello, myself Srishel Swami, working as assistant professor, Department of Electronics and Telecommunication Engineering from Walchand Institute of Technology, Solapur. These are the learning outcomes. At the end of this session, the students will be able to design the layout of combinational circuit using CMOS logic. Design schematic of 4:1 multiplexer using transmission gate by using the DSCH software. This is what the 4:1 multiplexer. Where are the there are the four inputs I0, I1, I2, I3. Depending on the select lines values, the input will be transmitted from the input to output line. So why is the output? So here the truth table is given. So based on the S1, S0 values, the particular input will be transmitted from input line to output line. So y is equal to S1 bar dot S0 bar dot I0 plus S1 bar dot S0 dot I1 plus S1 dot S0 bar dot I2 plus S1 dot S0 dot I3. So this is what the Boolean expression of the y, that is what output. So today we are going to design the 4:1 multiplexer using the CMOS logic. In that we are using the transmission gates. So by using the transmission gate, we can design the 4:1 mux, which is shown here. So there are the four inputs as I already explained, I0, I1, I2, I3. We to design the 4:1 mux, we required the total 6 transmission gates here, and we required, along with the four main inputs, we required two control inputs, that is what S0 and S1. So this is what the schematic we can design by using the DSCH software. DSCH, the simulation software we can use for the design of 4:1 mux. So here based on the values on the S0 and S1, we can transmit the input from input line to the output line. So we have to design this particular 4:1 mux using the micro wind as well as the DSCH. So this is what the another symbol of transmission gates. So here this is also representing the 4:1 mux using transmission gate only. The only difference compared to the previous diagram is what the symbol. Okay, both symbols are accepted as a transmission gate. So same, this we can prepare, this we can design by using DSCH. So this is what the design of 4:1 mux using transmission gate. So this we are going to design now. We can simulate, first of all we can design this, and then we can simulate to test the result, and we can verify the truth table of given 4:1 mux. Now we can start for the simulation. Now I will open the software, that is what the DSCH. So I will take first of all the NMOS. I will just rotate it right. Okay, and then I will take the PMOS. I will rotate it left. And then I will move it so that I will connect it. Now I will just zoom in so that the entire layout will be in a one diagram. Now I will copy it. Total number of transmission gate requires the 6. So in the first left side I requires total 4 just you can copy it and connect it. So this is what the 4 transmission gate requires at the first stage. I will select the input I0, I1, I2, I3. So this is what the I1, this is what the second one, I2. I will change the names so that we can use according to the circuit given in the PPT. Now I will change the name of this, so you can just double click on that. So you can give the name as I0. Next you can click it here, you can give the name as I1. Just you have to double click on this particular button which is known as input button. Then this is what I2. By using input button we can give the input as a 0 or 1. If you are pressing, it will give 1. If you are releasing, it will give as a 0. Next is last one is I3. So these are the 4 inputs. We need to connect it by using wire. We can connect it. So these 4 lines consider as a 4 input lines. Now we can consider the 1 control lines, which is we can consider this name as S1 or S0. So just we can see S0 here we are considering. So according to that we can consider S0. S0. So the NOT gate is required here because we need S0 bar also. So we can use NOT gate somewhere here. So we can connect it. So NOT gate S0 bar also we requires. So S0 bar first of all I will connect. So here S0 bar is needed at the top. Similarly at the center we require S0 bar. So you need to connect. S0 bar. Similarly the S0 you can connect at 2 places. Here is the one place. So according to the truth table and expression you can connect this S0 and S0 bar. So this is what the connection of the first stage we have completed. So output we are taking, output we can extend. So combinedly this will give the output. Then third stage I2 and I3 we can combine. Again we can design the fifth transmission gate we can design. So we can rotate right, then we can take NMOS or PMOS we can take now, and we can rotate it left. So we can connect this one so that we can form the transmission gate. So this we can copy one more. So just we can move it exact at correct location so that we can connect it easily. Now we can connect these two transmission gate each other. Now this we can connect the output of the first two stages I0 and I1 we can connect to the first transmission gate in the second stage, and output of I2 and I3 transmission gate we can connect in the second transmission gate in the second stage. Now we need to use this one, so we can make it copy. So only the name we can change here. Instead of S0, now we can make it S1. So we can connect now S1 at the center. And we can use this one to connect this line. We can connect here at the center. This S1 bar we can connect now. The output we can take as a LED so that we can get here. We can give the name, we can rename as a Y, and we can connect this at the output terminal. So output we can take from here. And output we can connect here. So this is what the entire schematic. Now we can just run it. Okay, so we can now kept 0 0, we can press I0. When I0 I will press by keeping S0 as a 0 and S1 as a 0. If I am keeping I0 as a 1, then it will transmit from input line to output. In case I will remove I0 and I will press I1, it will not pass. Similarly, if I will press I2, I2 also will not get passed. And if I will press I3, I3 also will not get passed, because the control lines are what? S0 as a 0, S1 as a 0. Now we can select I2, I1, I2 we can make 0, only I1 we can make it 1. In this case S0 I will keep 0 and S1 I will keep as a 1. Sorry, S0 as a 1 and S1 as a 0. So in this case it will transmit the 1 0 lines. Okay, so in this case if you are pressing this, it will press as a 1. Now if you are keeping S1 1 0, S1 as a 1 and S0 as a 0, then you have to press I2. So I2 you can get here as it will transmit. So lastly we can make S0 as a 1, S1 also 1, and we can make I3 as a 1. So it will pass I3 signal. So in this way we can verify the truth table. So this is what the entire design of 4:1 mux using the DSCH software. So by using this D schematic software, we can design any combinational circuit as well as any sequential circuit, as well as we can design also the memory circuit. We can design the components required for the ALU. We can design the any digital system by using the D schematic. So we can design by using the D schematic software. So these are the references referred.